send out the messages to the muscles. This is going to be all of our pre-motor cortex, and then the frontal, which is the biggest in us, and it's going to be really teeny in the little sheepies. The parietal lobes are going to be right underneath the parietal portion, the bones. So again, here's our central sulcus. So here's the parietal lobes. It goes all the way to this fissure and all the way to about here on the back of the brain. So if you can envision that lambdoidal suture, you're running right around the same area. So this is occipital lobe, parietals, and then down here is the temporal lobe. They want you to be able to find the corpus callosum. The corpus callosum is a band of tissue that connects the two halves of the cerebral hemisphere. So this is what it looks like when we cross-section through the brain. It's kind of described as like a horseshoe. So here it is. You would expect information to be traveling rapidly from one hemisphere to the next. And that's the best one we have here. In some of the models, you can actually take it out. This is actually what they used to sever, and still do sometimes for epileptics, to prevent grand mal seizures. They're going to sever the two halves of the cerebrum so that the information cannot travel electrically from one side to the other. So maybe that'll help. Septum pellucidum is that, again, that flap of tissue that we have to cut through in order to get to the ventricles. The fornix, they've gone ahead and put on in this pink color, so it's always really clear, and they always show it in pink. So even if we look at this other model, it's still in pink there. I don't know why they do that, but they do. There you go. The cortex is obviously all of that. I don't know why that's separate. Olfactory bulbs. So now we're going to get into cranial nerve land. So I'm going to put the brain back together since we're looking underneath it. The olfactory bulbs are the very end. Okay, so this is what's going to sit in that ethmoid bone, and then the tract, the olfactory tract, is actually what takes the information back. So notice that really and truly, the way that it's named, the olfactory nerve is not truly a cranial nerve. It's actually a projection of the brain itself. The optic nerves extend out from here, and we just see little stumps of them that they've cut off. The optic chiasm is this area right behind the pituitary. It's a little bit hard to see with my big old fingers in the way, but here it is. This is where it's the X portion. This is where the two halves of the visual world go ahead and get together, and the left goes to the right half of the brain and the right goes to the left. So it's where that nasal half of the world switches sides. The optic tract is in the area where it finally takes back to the brain all that information. So we have nerve, then chiasm, then tract back. Now what's cool is that each of the brains, if you look really closely as you study, is labeled 3, then it shows you 4, 5, 6. It goes through all the nerves with you. So what I recommend you do is start on the side where it's labeled and learn to count them. And count them in order so that you're going 3, 4, 5, 6, so forth and so on. If you count them in order every time, then you'll be able to count them. You'll come up with a muscle memory to count them in order as you move. And it can also help you if you look at that for a few minutes today and get the counting down. And again, they're labeled. So start on this side, going 9, 10, 11, and then back up to 12. And then see if you can apply it to this side. And once you can, you know where they originate from and all that good stuff. And then we did all the rest of it. So we could go into the diencephalon if you want. Do you want to keep going? Okay, so we have the pituitary gland.